Over the last 35 years, we've taken stretch wrapping from here to here. Along the way, we've learned some things that can change the way you think about stretch wrapping. Join us for the first episode in a series of podcasts that can help you learn to wrap better, faster, and at a lower cost. Hello, I'm Paul Stewart. Welcome to Lantech Now. Today I have Pat Lancaster with us, chairman of Lantech and inventor of stretch wrapping. Welcome, Pat.
Thank you.
I know Pat's been working on a major project for the last several years, driving and leading a team of talented engineers, machine designers, and technicians at Lantech on a project that has really pushed the envelope of stretch wrapping. In that, he's overcome a certain number of challenges and actually had an opportunity to advance the state of the art, and we want to try and get some information on those challenges and the implications of the learnings that he's had in this process. So Pat, can you give us just a little brief idea of what this project was and how you happened to get drawn into it?
The project started as a effort to get stretch wrappers to go much faster. In the process of trying to make them go faster, we came across the barriers that we previously experienced with how fast people thought stretch film could be pulled before bad things would happen. So we had to overcome a great many obstacles in order to go to these much higher speeds. So at the end of the day, the technology that we've been using for the last 35 years just wasn't adequate to take us there. That's right. It certainly wasn't.
So you kind of had to just go back and almost start from scratch and develop a whole new technology to do this?
We did. We had to figure out a whole new way to think about stretch wrapping pallet loads in order to be able to achieve those speeds.
So in doing this, I think it's fair to say that we kind of altered our perception of basic stretch wrapping and had a couple of learnings that may be relevant to our listeners.
We did. We learned a lot of new things, and we confirmed some old things that we maybe forgotten that we need to bring back forward again.
Well, if we go right back to fundamentals, at the end of the day, stretch wrapping is about getting a load from point A to point B, or a pallet from point A to point B. And we do that by taking a lot of little packages and turning it into a big package.
That's right. We call that unitization, and basically the stretch film's purpose is to surround the load and make many small packages act like one big package.
Well, what's the difference between that and, let's say, something really core like containment?
Well, containment is the whole idea that the amount of force that's put around the load causes all those individual containers to act like one. So we're not shipping a bunch of products that are moving around within that single unit, but shipping a product that acts like one single unit.
Now, you've brought some video that illustrates that point.
We did. And the first clip here, you can see where the load has been wrapped at a very low force, and you can see the internal activity that's taking place in the load. This is in a simulated shaker table, which is very much what it would look like if you were riding in the back of a truck. The second clip shows what happens when that containment force is dramatically increased, causing the load to act more like a single unit.
So clearly the differences in the first load, you can see that the load is not acting together or moving as a unit, but it's tightened up when the containment force is increased in the second clip quite dramatically.
That's right, and that we have found indicates a load that is going to stack better and ship better and arrive at a customer's location more intact and more in the condition that it was originally stacked.
So that's really containment, the point at which the load acts as a single unit. That's the proper amount of containment, right?
That's correct.
Now, does that vary from load to load?
It would. All kinds of loads are different. Paper towels are going to be different than water-filled bottles, are going to be different than display loads. One is going to have its own individual characteristic, but each one will be enhanced with the proper level of containment force.
How do I know, if I'm a manufacturer, what the proper containment for my specific load is?
It's a very difficult question. We came up with a very simple answer, and it is basically to determine the containment force that is currently successful, to understand that currently many of our customers are shipping products successfully. So if we can merely evaluate the containment force that is on those and make sure that whatever we change, as we speed it up, as we change films, as we change gauge, as we change pre-stretch, that we don't do anything to detract from the containment force that has been successful.
So as a practical matter, we look at what's working now and start from there.
That's the best place I know to start.
Okay. Well, one of the key issues, again, is how do I, once I know what my containment force is, how can I be sure I'm getting it consistently?
Well, of course, that leads to the second big problem, which is there was no measurement tool that we could find that was very reliable, that didn't have a lot of operator error to be able to determine containment force. So we went through a development process as well to develop a tool that would give customers a pretty good sense of whether they had matched the containment force on their current shipments to the containment force in this baseline of successful shipments.
So I've got to understand containment force. I have to be able to measure it accurately, and probably our previous tools weren't quite good enough to give us the accuracy that we needed. And then I suppose at some point we need to put in some kind of process controls to make sure we're consistently getting it?
That's right. It will be extremely important to verify that the containment force that we're getting is the containment force we want, and we need to verify that on a quite frequent basis. And if it varies from the containment force we want, we have to root cause why it changed and fix those changes.
So at the end of the day, the core principles of stretch wrapping are the same. We're just probably looking at them in a little bit different light.
We're looking at them with a little more precision and a little more concern that we really do it right.
Pat, thank you for sharing that with us. Join us next time and learn how to measure containment force accurately. For more information on stretch wrapping, visit us at lantech.com.